First of all, a little introduction of myself. I'm Raffael. I'm a platform engineer at AXA. And I, in the recent years, delved deep into the realm of platform engineering and internal developer platforms. And especially in my recent master thesis, which I finally finished, I tinkered around with OAM, the Open Application Model, and KubeVela. Now, before I really begin, I'm interested, just a show of hands, who has heard of OAM or KubeVela or possibly has already used it? Nobody, even better? One? Okay, so everyone can learn something hopefully today. Before I forget, KubeVela is a CNCF incubating project at the moment, so one of the big boxes. Maybe you have seen it on the website, on the landscape, but don't quite remember. I don't know. All right, I want to start with kind of a motivation why I think these tools are cool, and thought about what DevOps brought us. It brought us, you build it, you run it, which sounds great in theory, but is it also in practice? What I see, at least in my company and when I speak with people, is, well, in reality, developers want to ship their applications, but regularly they're held up by platform complexity and by tooling complexity especially. And nowadays, developers have to juggle a multitude of different tools and platforms, starting from cloud service provider across Kubernetes, OpenShift, Helm, Argo CD, Terraform, you name it, the list goes on and on. If you look at the landscape, it's probably everything that's on the cloud native computing landscape. And at the same time, not only developers are struggling, but also platform engineers are struggling to standardize the ever so slight differences between this product team and that product team and another product team, because, well, every team does it somewhat similar, but reinvents the wheel again a bit differently. So in the end, the conclusion is everybody's overbound, everybody has cognitive overload, nobody really wins. So we have on one side developers that are drowning in platform concerns, on the other side we have platform engineers trying to wrangle chaos. So if you take a step back, what would be a proper solution to possibly fix this, and what do these groups actually want? Let's have a look at that first. Now please keep in mind the points are listed here are purely my experience and my research. You might see it differently. Happy to discuss. What developers want, the most important points in my eyes, are they want to define apps and not low-level resources. They want to define that whatever container image should run somewhere, they don't care where it really runs, they don't care if it's scaled to 100 or 0, it should just be there when the customer accesses the app. Or for example, a database, they just want a Postgres database. They don't care if it runs on RDS, if it runs on Kubernetes itself, if it's some self-hosted service, it doesn't really matter. And then linking to that, they want to ship without infrastructure expertise. So usually what I see, they don't want to write complicated Terraform configurations. They don't want to work with Azure, AWS, GCP CLIs to manage their infrastructure. And last but not least, they want to focus on business logic. In the end, that's what they get paid for and what they should do best because they are software engineers. There's another side to that. What do platform engineers want? And here I count myself into these 3 points especially. I want to standardize configurations. I want to prevent that sprawl. I want to have most of the configurations similar so that everything is secure and compliant. And ideally, I want to offer these things as reusable building blocks to my developers or to my customers in that sense. Well, what we actually need, or what could be a solution to this, is proper separation of concerns, where developers can focus on their application definition or what to run, and platform engineers can focus on how to deliver what developers need in a reliable, secure, and efficient way. So how do we make that magical tool? And one solution to that could be dynamic configuration management. Maybe someone has heard the term already. In this talk specifically, it's dynamic configuration management with the Open Application Model and KubeVela. And how it all works is depicted in that diagram. So developers, they write so-called OAM applications, Open Application Model applications, which is an abstract definition of what an application should look like. It doesn't contain any real technical intricacies of what it is in the Kubernetes world or in the cloud provider world. It just says that's a component and that's a trait that's attached to the component. We will see it afterwards in the demo. And platform engineers, on the other hand, write so-called OAM definitions, which are these reusable basic building blocks which then developers can stitch together into their specific application. And the clue behind the whole concept of dynamic configuration management is actually that while this is not enough to get deployed on any platform, it's too abstract, it's just a blueprint of how it should look like. And while these are just building blocks, KubeVela, the motor in the middle, kinda, upon every deployment, takes these two things and renders deployable Kubernetes manifests out of it. So, yeah, upon every deployment, you get a fresh set of Kubernetes manifests, and you can guarantee, from platform engineer perspective, that it's always up to date. So, if you need to do some, I don't know, changes because of compliance requirements, you just put it once into your OAM definition, and once every application team has done a deployment, it should be updated in all their Kubernetes manifests that are actually deployed. And by the way, the dashed line means that we are not creating silos as we had it before, but developers are obviously also invited to contribute in that OAM definitions if they have good ideas to contribute to that whole endeavor. So that's the theory. Now let me show you how this works in practice. We will see how developers write OAM applications, how it looks like. We will see how they can discover OAM definitions to stitch together their applications, and we will see how the whole process through KubeVela works. And it's demo time. Right, let me switch to my terminal. I hope it's big enough, otherwise I can still make it bigger. Just raise your hand if it's too small. Okay. No problem. Where is it? Here it is. I have a weird keyboard layout, so I can't remember the shortcuts. Right. So first of all, I, as a developer, maybe want to find out what's available in my cluster. There's the Vela CLI, which interacts with the KubeVela deployment. By the way, I'm doing this. Oh, the format is horrible. It should be a table actually, but you can see it's not really readable. But fortunately, there is not only Vela definition list, there is also Vela show --web, which starts a local web server and then gives us a web page that basically describes all these components, traits, workflow steps, and policies that are available in that actual cluster. I will only focus on components and traits today. The other things are maybe something to discuss in the upper row. Let's see. So I just want to show one example. For example, web service is probably one of the most used ones. It describes a long-running, scalable, containerized service. Maybe make it a bit bigger. That have a stable network endpoint to receive external network traffic from customers. So that's a typical combination of Kubernetes deployment plus a service to expose whatever you want on the cluster. You have an example here to see how it works, and there is a detailed specification you maybe know from similar Kubernetes docs pages. I won't go much into detail because I actually want to show you a real example of my sample application I used here. And maybe let's have a look at the architecture first. It's probably a bit smarter. That's the sample application I used. Maybe you recognize it. It's taken from the Docker samples. It's called the voting app. It is comprised of 5 components. You can vote on the Python vote front end. The vote gets sent to a Redis cache. The worker, .NET worker, processes the vote, persists it in the Postgres database, and the Postgres database is then queried by the Node.js result front end to display the result. So this just for context. Now let's look at such an OAM application definition. Yeah, well, it's just API version something OAM, right? Kind application, and we give it a name as everything in the Kubernetes world. And then in the spec we have components. So first of all, we have the result component, which is of type web service, the one we looked at before. And the only things I need to supply here are my image. I always want to pull it because I'm experimenting a lot here. I need a pull secret. I have my images on GitHub container registry. And then I say I want to expose port 8081. And because it's some weird dev setup, I just hard code my credentials in here. It will get better as soon as we evolve the application. Okay, so as you can see, no mention of deployment, no mention of a service. I absolutely don't have to know what's going on inside Kubernetes. I can just write this definition and my application will or should work in the end. Then we have the same for the vote. It just has a Redis connection details because it needs to interact with the cache. The worker looks quite similar. It is of type worker, which is basically the same as a web service, just without the Kubernetes service part, without the network exposure. This one needs to connect to both data stores. Then we have Redis as a web service as well, with some mtdir volume mount, and Postgres as a web service as well, with another mtdir volume mount. So we can now deploy this using the Vela CLI again. Let me cancel that command, and I can do Vela up-f. It reminds me a bit of Docker Compose, probably, a long time ago. I can do that. Then it will, the OAM application definition will get sent to the KubeVela server, which is running in my Kubernetes cluster, in my EKS cluster. And, well, it will get started. We can then see the status also through the Vela CLI. It will print a lot of green ticks, which is quite good, so it worked. But we can also have a look. By the way, I have very, very many aliases set up in my shell. So KGA, for example, is just kubectl get all because I'm tired of typing the same things over and over again. So we can see 5 pods running, 4 services, 5 deployments, exactly what we expected, right? So much for the simple case. Now I want to switch over because, well, the Vela CLI might not be the most accessible thing, right? I spoke about relieving developers, so why overload them with a new CLI? Well, we can also hook this into Argo CD actually, or that's what I did at least. Let me delete that application first, because otherwise it will mess with my Argo CD application. I will just delete it here. It asks me for confirmation, and it should be gone in a second. Let's check. No resources there. Right. So I already prepared this because we don't have much time. I have a voting application in Argo CD already. It is currently out of sync. Obviously, when I look at the diff, I need to refresh it because it took up my state from before. Yeah, well, now it's missing what I expected. And we can see, I won't go through everything, but it will just create again 5 services, 4 services, 5 deployments, and so on and so forth. Let's sync this because I just want to have it on a proper state to then evolve it with additional edits. So now we have deployed it via Argo CD, and maybe what's worth mentioning, we are actually using KubeVela now only in the client-side mode, not in the server-side mode as before. And how it's done, actually, it's just a Argo CD config management plugin that calls, it's a command, Vela dry run. I can quickly show you here with that example. It's actually what happens in the background. Oh, I forgot the dash f. It will actually just this is the command that renders my abstract definition into deployable Kubernetes manifest. We have a lot of labels additionally, but in the end you can see it just renders deployments and services. So nothing new, nothing magic. All right, let's evolve this a bit, and let's say I want to expose my application now. Let me actually compare these two. As you can see, what changes from the 1-basic to 2-gateway trait version is that we now have, we remove that expose equals true, and we instead add a trait. Trait can be added to components individually to augment them with whatever you need, scaling, exposure. What we now want is exposure. I want an ingress for that service, specifically the result service, and I want to have it on /result port 8081, and I want the same for the vote service on another route and another port. So because I'm lazy, I'm now ignoring GitOps concepts and I'm just editing my Argo CD app live in here, but it will be good enough for a demo, I would say. Gateway trait. Let's save it, and now we can see how it progresses from the previous version. It is out of sync. That's actually what we expected, and then we can see the rendered difference between what we had before. So some labels are changed. We don't really care about that. This is just OAM internal management and categorization of resources. But what we actually get is an ingress resource for the result service and an ingress resource for the vote service. And we don't ever have to know about ingress. All right, let's sync this as well. And then I can quickly show you what happens in the background. Because I'm on AWS and I'm on EKS, the most convenient solution is just to use an ALB and link it to my EKS cluster. And we should shortly see here that an ALB is being provisioned. It will take 2 to 3 minutes, so I will not wait for it to be ready. You just have to trust me that my application will be available. Otherwise, I can show it to you afterwards. I'm not lying. Tested it beforehand. Right, okay, so that's the second case. Then we can go one step further, and yeah, let's say we don't want to host our data stores on Kubernetes, especially with these weird hard-coded credentials. Let's say I want to use AWS data stores since I'm already anyway on AWS. So let's compare the next two files. Let me start at the bottom here. What changes here is I changed the Postgres service, Postgres component from web service to AWS RDS, which is actually a component I wrote myself, which has Terraform in the background. We will probably see it afterwards. And it gets much simpler because I don't need to supply all these environment variables. I don't need to do any volume mounts. I actually just give it an identifier. I say I want the Postgres engine, I want that version, and then write the connection details to a Kubernetes secret. And more or less the same for Redis. It's AWS Elastic Cache. I just need to name the engine and tell it to write the connection details to a secret. And what is really cool in my opinion now, I don't need to pull these connection details, connection strings ever out of Kubernetes. I can just consume it in my environment variable from a secret key ref, which we already know from default vanilla Kubernetes. And we actually do this for all these 3 services, depending on what they really need. All right, let's again just hack the new version in here. It is 3 AWS data stores. And then we can see the actual render difference as well. Let's look at the difference, and we can see, well, Postgres service is being deleted, that's fine. Deployments are deleted as well. These are just the secret key refs, that's not that interesting, but what is interesting, here we have a configuration definition from the KubeVela Terraform controller, and it actually just contains plain HCL, which you might know, you might have seen. It's quite a sophisticated definition to cover all the possible use cases. But again, I don't ever have to see this as a developer. I just use this 1 or 2 or 3 inputs I care about, and the rest I can leave to the platform engineer who will decide about the defaults. And obviously it's more or less the same for the Redis example with the Elastic Cache. So once again, let's sync this. I activate the prune option to get rid of my old deployments. Prune, right. And what we can see now is that we have two configurations in here that get spawned. These are actually these Terraform configurations. And of course, my services will now be unhealthy for some time because deploying RDS or Elastic Cache takes about 5 to 10 minutes. It's only an example app, so I can live with the outage. Maybe we will see something when I go look in AWS, but maybe the Terraform apply hasn't started yet, not yet. Let's have a look in the terminal quickly. I can show you what happens under the hood if I get all my pods. We have now two Postgres, we have two apply pods running, Postgres apply and the Redis apply, and this is actually the pod where the Terraform controller is running. And if I look at the logs of this pod, okay, seems that Terraform executor has just been started. Before it runs a Terraform init, as always. And then as soon as Terraform executor starts, it takes some time. We will see the plan output as we know it, or at least as I know it. Not sure how familiar you all are with Terraform. We'll see the plan output, and then it will just get immediately applied. Yeah, here's the plan output. So if I'm suspicious, I can still check what's going on under the hood as a developer even. And well, now we should also see these resources getting deployed or created in AWS. Exactly. Now it's creating. And the same should be the case for this Redis Elastic Cache, which is also creating. Again, since it takes 5 to 10 minutes, I will not wait until it's over, but I can happily show you the result afterwards if you're interested. And that already concludes my talk. I hope I didn't rush it too much. If not, I'm happy to take questions.